Hi, welcome to this first introductory lecture on data visualization. We'll look at some of the reasons and some of the principles here before we dive into individual topics in the next few lectures. So we're going to talk a little bit about exploratory data analysis. This exploratory data analysis is a term coined in the 1970s by Chuki, where he was trying to get over that before you statistically analyze data, it can be a very good idea to draw it, to understand the shape of it and to understand what might be important in there. So, what's the process of visualization? What's the role of visualization? This diagram tries to illustrate how visualization produces ideas from data. So on the left of the diagram you'll see a cloud. Very often our data is stored in a cloud. It streams through a pipeline and is processed and turned into an image displayed on some kind of, usually electronic display, but also printed and other forms of display. The part between the display and the eye, light waves carry information to your brain. Your eyes detect it, your brain thinks of ideas, and hopefully those ideas are the ones that the visualization designers wanted you to think of, and allows you to explore and create layers of information and knowledge about whatever data is on show on the display. Visualizations have many roles. They're often designed for communication. How to describe and explain ideas. Here maybe in entertainment or learning situations. Confirmation, so monitoring streams of data, monitoring that power stations or IoT sensors or wind farms are working as you would like them to be. And then also here exploring and analysing data and public service data, for example, as this is recorded, the data about the COVID infection. There's huge amounts of data flowing around the world and people are exploring it to try and understand it and understand the state of the infection in different parts of the world. So as well as these roles, it's important to remember that visualizations are created and exist inside a subjective context, and the images that are created by and for and interpreted and understood by people. And this process is influenced by many factors, which includes the aesthetic, the social, cultural, emotional and epistemological context, the belief systems of the people seeing the pictures. To a large extent, the science and engineering of visualization tries to say what visualization tools can we agree on, or can we propose that should be interpreted in a consistent way by people. But all of these factors come into a final idea from a visualization inside the mind. Is visualization important? Well, in 2009, Hal Varian, Google's chief economist, thought so. And he said this ability to visualize data is going to be a hugely important skill over the coming decades, and that this is in part because we have essentially free and ubiquitous data. And you can see that in data now. It's huge amounts of data in the world, not always the right data and not always the data you would want, but huge amounts of data. And we need to understand how to use that. Perhaps what's changed since then is people have become much more understanding of the need for privacy in data and security of data. It's not just a huge amount of data out there to exploit. There are some important privacy issues behind that. So if you're unconvinced, perhaps that data visualization is worthwhile, have a look at this table here. It shows a certain set of values, triglyceride levels by gender, age and income, and just give yourself 5 seconds to decide which gender or income group shows a noticeably different trend with age. Okay, or you can plot a graph and you'll see instantly that its females in a low-income group have a different trend. That's how quickly trends and patterns can be formed in the mind from data, which is different from numbers, which will give you a quantitative absolute value for things. So, exploratory data analysis, very often people come to you with data, not even knowing the questions they want to ask about the data, but knowing that the data might have some answers in it. And so Chuki started this, wrote a book about exploratory data analysis, which is well worth reading, and started to use visualization as a way to get intuitive understanding of data before you go in and analyze it. Among other things, he invented the box and whisker diagrams, and these were based on this 5-number summary of data. We won't spend time on those now, but well worth reading. Back in time, some of the earliest visualizations were by William Playfair in 1786. He plotted these almost stream graphs and bar charts, almost all related to trade and the balances of trade between England and other places. Today, even now, some years after Google said that visualization was going to be a requirement, data is collecting these huge lakes. It's starting to be more difficult to get the data you want. There's starting to be good privacy protection, and there's starting to be hidden data. But very much you can go out and acquire a huge quantity of data, but you then need to mine it and refine it before it becomes a useful commodity. And this is one way to look at what visualization helps do in that refining process. You go from, if you look at the DIKW pyramid, you go from data to have information, to have knowledge, and then wisdom. Data here is just symbols and signs. Information is structured data. Knowledge is something that's understood by a human being. And wisdom, of course, comes with time and age, we all hope. And the role of visualization I describe here as accelerating this process of going from data through information and knowledge to wisdom. There are lots of useless data visualizations, and Edward Tufte coined a word for this, Chartjunk. Not only for this reason, but many other reasons. This plot of diamonds were a girl's best friend, showing the sales of diamonds from 1978 to 1982, has a number of concerning features which it would not be used these days, but it used an image as an attempt to make you remember data or interpret it in some way. Tufte argues that you should make these visualizations very plain and very linear. But in 2013, my friend Michelle Borkin did a study, and she showed that if you have these very sparse visualizations, they can be very hard to remember. And that in some way, if a visualization has a key image to it, and the scenes are more natural looking, it helps you remember what you're seeing, or helps you remember of the visualization to go and look it up to see what's there. I wouldn't advocate the design at the top of the page, but it's of its time. A second factor that has come to be used in the visualization literature and discussions about visualizations is the lie factor. And this comes up time and again in different ways. The lie factor is when you have a piece of data, its size in the image should be the same as its size in the data. So there should always be a 1-to-1 ratio between the size of data and its graphical representation. This particular visualization here doesn't do that at all, and in fact when you work out the lie factor, it's about 15 times because of the forced perspective in this road, and it makes it look like there's been a huge change in fuel economy standards when there wasn't. Another more difficult example of life factor is logarithmic scales. People in some of the sciences use logarithmic scales all the time, but these distort data and make small differences at the small end of the scale look big, and very large differences at the top end of the scale almost vanish altogether. That's on purpose to show very large orders of magnitude in the visualization, but it has quite a significant life factor for anyone not familiar with logarithmics. Okay, what kind of things can you do? Well, simplicity is always good. This shows American presidents. 100% were male, 100% were white, and 100% were Christian. Until 2007 when Obama came along, and then Trump came back, and things were back on track again. It conveys a very straightforward data message, but also a very stark political message. Similar, very simple line graph Al Gore used in his very famous film An Inconvenient Truth about climate change, where he showed the many thousands of years, hundreds of thousands of years of CO2 levels in the atmosphere, which had stayed fairly constant within a certain range, and then just at the Industrial Revolution and up to today has shot up hugely. He famously did this on a apple picking type platform, where he actually physically levitated up to the top of the graph, which is a great way of showing directly, a visual meme showing directly something that's perhaps more memorable than just a line graph. So, key points of EDA. The roles of visualization, they're about communicating, they're about confirming and exploring data. Exploratory data analysis is hugely important in understanding data before you dive in and do an analysis, if you can do it. And in fact, often it's the only way to start to understand which analysis to apply, because how the data is shaped can affect your choice of analytic tools. And finally, simplicity. While it's good to reduce the amount of ink on a page, it's not always memorable. So use the ink on the page to show your message and get across memorability in it, but always on the side of clarity. And we'll talk about that itself later in this course. The value of information, well, Philosophia, friend of wisdom from the Greeks, perhaps started us thinking on this. And T.S. Eliot, very ahead of his time in talking about where's the life we've lost in living, where's the wisdom we have lost in knowledge, where's the knowledge we have lost in information, and you might these days add, where's the information we have lost in data. Something to think about there. Okay, thank you for listening, and we'll be back soon.